All right, we're rolling. All right, we got 6.4 mid segments. Okay, so what is a mid segment? It's exactly what it sounds like. It is a segment from the midpoints. Okay, so we got the triangle mid segment theorem, and it has some properties we can use as well, and also makes some pretty cool shapes. So let's take a look. All right, let's start with what is a mid segment. Okay. All right, so what is a mid-segment? A mid-segment connects two adjacent midpoints, okay? Segment connecting two adjacent, meaning next to each other. Should probably spell adjacent the right way. There's a J there. Two adjacent midpoints. All right, so if you haven't caught on at this point, we draw a lot of triangles this chapter. So it probably will be helpful if you have a ruler. And we're going to draw a triangle, put midpoints on it, and then we're going to connect it to show you what a mid-segment looks like, okay? Why don't you get a ruler, and let's draw some triangles. We'll do two examples here, okay? We'll do one obtuse triangle and one acute triangle so you can just see both. Let's do an obtuse triangle. And let's just do something like this. Why not? Okay? And maybe I'll just fill up the space here so I'm not. What am I doing? Yeah, let's do this. Okay, stop messing with it. It's fine. Okay, so now what we're going to do is we're going to make a midpoint on each side, kind of like we do for medians, but we're not going to connect it in the same way. So if you have a ruler, just measure the middle. If not, it's fine. If you guesstimate, should work out close enough for our needs here. Okay, so each of these are midpoints, okay? I cut the sides in half exactly, and now we're going to connect them to the adjacent midpoint, just like that. Okay? And like that, and like that. Okay, so that's what it looks like for, this doesn't really look obtuse, does it? It looks more like a right triangle. But we'll do one like that, and we'll do one that's more clearly acute so you can see what we end up with, all right? And let's make it equilateral. Okay, usually we avoid them, but it shouldn't hurt us in this case. You'll still see what's going on. So let's make an equilateral triangle. Do my best here. Is that equilateral? That's pretty close. We'll take it. All right, so let's do another one. Do the same thing, right? Midpoints and connect them. I think it's close enough. Yeah, that'll work. Boom, there we go. All right, so we got two mid-segment triangles. So we draw all the mid-segments on the triangle, okay? Then they don't cross at one location, so we don't really have like a word for like centroid or incenter or anything like that. They're just mid-segments, okay? So we have the mid-segment theorem, which says, first of all, a mid-segment must, two things, there's two things. A mid-segment must be parallel to the opposite side of the triangle. Okay, so let's label that in this one here. Okay, so here's what we can say. We can say that this must be parallel to this. All right, so this side must be parallel to this mid-segment. Okay, so similarly, we could say that this must be parallel to this one here. It's true for any midsegment. There's no proof that proves this, but just take my word on it for now. They are completely parallel. All right, so there's that. And this one would be parallel to this. There you go. Okay, so we have parallel lines and or segments, I should say, and that's the first property. Okay, so first they have to be parallel. Second property, so we'll just call this property number 1. Second property, a midsegment must be half the length. The length of the opposite side of the triangle. A midsegment must be half the length of the opposite side of the triangle. Okay, so we'll label that on this one here. So we got 2, so it doesn't get too cluttered. All right, if I told you that this length here, from here to here, was 12, that full side of the triangle was 12, we would know that this matching midsegment, the opposite, it has to be 6. All right, and if I told you that this one was 5, this length of the triangle is 5, you would tell me that this midsegment is 2.5, because we just divide 5 by 2. Okay? So those are the 2 properties. They're pretty straightforward. Not too difficult to remember, honestly, because it makes sense kind of looking at the picture. And it's not like a fraction like 2/3, it's just half, right? So that's a midsegment. Let's see what we can do with that. All right, so they're going to ask you a couple things in your textbook, and I'll add on the test as well. And you're going to be asked to say if they're parallel and find lengths, okay? So why don't you jot this triangle down? And it does matter that we know the points, because we are going to end up using distance formula. So yeah, jot this down, and we're going to show it's parallel and that the distance is really half. We're going to show it, right? Okay, so to parallel, that's just slopes, right? It's on a graph. We're going to find the slopes. If they're the same, then we can say they're parallel. So let's find the slope. So these are slopes. Let's find the slope of MN, and then we'll find the slope of JL. All right, M to N. So going down 1/4. That would be -1/4. And JL, we're going down 2/8. So -2/8, which is the same as -1/4. Okay, everything checks out. 1/4 is, or -1/4 is the same as -1/4. So we can say that they are parallel. So we can say segment MN is parallel to segment JL. And that's how you'd write your assignments for your textbook or on a test as well. All right, part 1 complete. Now that's the easy part. The distance, showing that is not as easy, okay? Because in order to find distance, we need distance formula, okay? So if you don't remember, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And you can use Pythagorean theorem as well, but I'm going to use distance formula for what we're doing. All right, so that part's done. They're parallel. Let's do distance now. All right, now it is going to be helpful if we know the coordinates of everything. So, okay, we know that J is -6, 1, and L is 2, -1. But let's just list the coordinates of M and N so we're all on the same page here, right? So M is -4, 3, negative 4, 3, and n is 0, 2. So if you remember distance formula, go ahead, pause the video, find the distance between these two, find the distance between these two. You're just really plugging into that that formula and seeing what you get. You'll get a square root, okay? It's going to be square root as your answer. Then we'll talk about what to do from there. All right, I'll go ahead and do it now. So we're going to go x2 minus x1, so that's 2 minus negative 6. So this is going to be the distance, and I'm going to start with j to l. All right, 2 minus negative 6, so square root of 2 minus negative 6. And then I'm going to do negative 1 minus 1. Oh, sorry, I should square this. So that's squared plus negative 1 minus 1 squared. And then I just simplify the parentheses, square it, add it, just do order of operations. All right, 2 minus negative 6, that's really adding, so that's going to be 8. So we get the square root of 8 squared plus negative 1 minus 1 is negative 2 squared. Now me personally, I like to make sure the numbers I'm getting make sense. Okay, this is telling me that left and right we're moving 8 spaces and up and down we're moving 2 spaces. Okay, does that check out with what we have here? It's 8 to the right, 2 down, 8 right, 2 down. It's all checking out. I can keep going. All right, 8 squared is 64, so 64 and 4 make 68, so I'm going to get square root of 68. All right, I'm going to pause there. I'll come back to that when I grab a calculator, because I'll need that later. But let's go ahead and do mn. Mn, we're going to do a big square root. And same thing, x2 minus x1, 0 minus negative 4 squared. I add that to 2 minus 3 squared. All right, I get the square root of 4 squared plus negative 1 squared. Does that make sense? I'm going down 1 over 4, so it all checks out. 4 and negative 1. This will be 16 and 16 and 1. So I got the square root of 17. All right. Now what on earth do we do here? How do we tell that this, they want us to say that this is half of this? Well, grab your calculator. We can check that pretty easily. And I'm getting mine. Here it is. Got my handy dandy 30x. So now I'm going to do the square root of 68. And I always do 3 decimal places. So we're going to do 8.246. So it's 8.246 units. And we'll do the square root. Square root of 17, which is 4.123. Units. And now we look, okay? Is this double this? So if I take 4.123 times 2, I get the exact same number here, okay? So it all checks out, yes. Mn is 1/2 of JL, okay? So I said they're 1/2, I said they're parallel, we're done, okay? Obviously this first part is pretty quick, just find the slope, and this can be kind of a slog. Now, it really is only painful because it's been a while since we've done distance formula. You'll get back in the rhythm of it pretty quick, but yeah, if you've totally forgot distance formula, it'll take a little bit to get back up to speed, all right? All right, I think that's all I was going to show you. Just make sure. Oh, ding dong. Yeah, I think that's it. All right. Well, if that's all I was. Oh, nope, sorry, there's one other thing. Okay. There's going to be word problems. And this one's not as much work, but we got to talk about a word problem. All right? So, it was. Which one do I want to show you? This one. Okay. Now, I'll leave it up to you, okay? If you just want to write down your solution and not copy all this down, that's fine. But regardless, you can pause the video here, write it down if you want, and then I'll go ahead and do it, okay? All right, let's read. Elm Street intersects Cherry Street and Peach Street at their midpoints. Okay, so they're saying that this Elm Street is a mid-segment. Okay, so we can use all those same properties. All right, so that's Elm Street is a mid-segment. Midpoint speed. You leave your home and jog down Cherry Street. All right, I'm gonna trace this. You leave your home. Where's your home? Home is at point P. You leave your home and jog down Cherry Street to Oak Street. So you go all the way down here. Okay, that's your first leg. Over Oak Street to Peach Street. Okay, then you go here. Up Peach Street to Elm Street. So you stop at Elm Street. Okay. Where was I at? Up Peach Street to Elm Street. Over Elm Street to Cherry Street. Over Elm Street to Cherry Street. And back up Cherry Street. To your home, it sounds like. Okay. How many miles did you jog? Okay. Let's take a look here. Now, we have to fill in some numbers here that we're missing because they don't give us every single distance. So this is still the track. We're going to add all these up, and that'll be your answer. But let's fill in the blanks on what we're missing from our triangle here. First of all, this length right here, Elm Street, we should be able to figure that out because it's a mid-segment, and we have the opposite side as 1.4. So it's got to be half. So 1.4 divided by 2, we get 0.7. That's a 7. Okay. So 0.7. And we're missing this here. Okay. They tell us half is 1.3. Remember, this is a mid-segment, so it's cutting this in half. It's right exactly in the middle. So this length right here is also 1.3. All right, just add it up and see what we get. So our first leg is going to be 2.6. Well, I'll just write them both out. So the 1.3 and 1.3, that's our first leg here. And then we go across, plus 1.4. All right, and then we go up. Oh, I forgot one. Okay. This is also a midpoint here, so we can cut this in half. Oops, I should have done that first. 2.25 divided by 2, you can type that in your calculator, and we get 2.25 divided by 2, and we get 1.125. Should have known that. All right, so we add 1.125, and then I add 0.7, and then I add this last leg, which is 1.3, and that'll give me my answer. So let's add them all up, see how far you jogged, and just take your time, don't mistype something. Okay, 1.7 plus 1.3. All right, I don't think I skipped something. Wait, let me type it in again. 1.3, 1.3, 1.4, 1.125, 0.7, and 1.3. 1.125 plus 0.7 plus 1.3. All right, 7.125. 7.125 miles. Okay, so that is it. Let me just double check here. Yeah, that's it. Okay. That's all I want to show you. That's mid segments. And have a good day. And bye-bye.